There are times when you are working on data or functions and it needs to be plotted or evaluated logarithmically. For example, it could be something like a power spectral density plot or a Bode plot. This video is actually set up for future videos on Bode plots. Anyhow, here I am in Mathcad and I've got a function of interest and I need to plot it, and I know that it needs to be evaluated logarithmically. A range variable is not going to work in this situation. Let's take a look at some examples of range variables. I will create one called linear range 1 for a linear range variable. And if I go to the operators drop-down menu, down at the bottom, this will create a range variable with a step size of 1. Let's take a look at that. So I will enter a value of 1 into the first placeholder. I will use the right arrow key on the keyboard 2 times in order to get to the placeholder on the right hand side. Let me enter in a value of 12. So here I'm creating a linear range variable that goes from 1 to 12. Let's evaluate that. Let's type in lin range 1 and then the equal sign. There you see the values from 1 to 12. You could also do one with a user-defined step size. Let me delete this. I selected it and then used the delete key on the keyboard. And let's type in our other range variable, linear range 2. I'm going to use the keyboard shortcut of the colon key for the definition operator. Once again, I will go to the operators drop-down menu, and then I will use the one over to the right for a step range. This is where you're going to specify 3 different variables or values: the initial value, the second value, which will define the step, and then the final value. The keyboard shortcut for this is the comma key. So let me click on it, and let's start out with a value of 1. Then I'll use the right arrow key, and then let's enter in 1.1, and let's go up to a value of 2.5. Let's click outside and then evaluate this one, lin underscore range underscore 2. Then I will use the equal sign, and let's grab this and drag it out. And so here we are getting our vector of values from 1 through 2.5 with a step of 0.1. So again, if I wanted to evaluate this function logarithmically, it's not going to be great doing that with a standard range variable or a step range variable, just because I'm going to have these humongous vectors. And so for that reason, we have other different functions that we can use. And those functions, as you can see from the title up here, are log points and log space. So let's start out by creating another range variable. And for this one, let's keep it easy. Let's call it A is going to be equal to, and I will go to the functions tab and let's go to all functions. The first one that we'll take a look at is log points. And that one's going to be in the category vector and matrix. And so let me scroll down till we find it. Here we have log points. Let me let my mouse stay over that for a moment so we can see the tooltip. And so this is going to take 3 different values. It's going to be the minimum exponent for 10 to the minimum exponent, then the number of decades that you want, and then the number of points within each of those decades. Oops, my tooltip went away. And if you need more information about this, you can use the F1 key. But I'm going to double click on that in order to get it in my worksheet. Let's start out with a very simple example. Let's start out with a minimum exponent of 0. So we're going to start out at a value of 10 to the 0. 10 to the 0 equals 1. And then let me cursor over. And I'm going to do this for 3 decades. In other words, it'll be from 10 to the 0, which is 1, 1 to 10, 10 to 100, and 100 to 1,000. And then let's enter in the number of points that we want in each decade. I'll use a value of 4. So this is keeping it nice and simple. So now let's evaluate A. A is equal to, all right, let me see, we have our first value of 1, and then we have 4 values. So these are the 4 values in the first decade. Then we have the start of the second decade. So it starts at a value of 10. And you'll notice that these values in the second decade are essentially just the values in the first decade multiplied by 10. So again, they are evenly spaced over the next decade. And then we have our third decade. Here's the third decade. And it goes from 100 to 1,000. And it doesn't go up to the ending value of like 1,000. But between 100 and the next decade, here are the 4 different values that you have. Be aware that there is a placeholder here, so you can use units with this. For example, maybe this needs a unit of hertz applied to it. Let me delete this. So there's an example of log points. This is the first function that you can use. Let me type in a new variable. We'll use b. Then I'll use the colon key shortcut for the definition operator. Now we're going to use the log space function. Let's go find log space. Let me scroll up. I'm going to collapse the vector and matrix group because log space is located in a different group. It's located in the log and exponential group, and here is log space. And this is also going to take 3 different values. It'll have the minimum value, the maximum value, and the number of points logarithmically spaced in between the minimum value and the maximum value. And so once again, I will double click in order to get it on my worksheet. And let's use something relatively simple for what we used for A. I'm going to start out at a value of 1. This is going to be the minimum value in the range. And then let me cursor over. I'm going to use a maximum value of 1,000. And then let's go to, let's see, the third placeholders, the number of points that we want in between there. Let me use a value of 12. And so I will click outside of that math region. Now let's evaluate. B is equal to, and here we have the different values. I'm going to make this a little bit easier to read. Let me go to math formatting. Let me change from general formatting to decimal formatting. And I really don't need to see all those different decimal places. And so here we have our minimum value of 1. Here's the maximum value of 1,000. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 values within that range. And so that's how you use log space. And you'll notice that this was actually different from the values in A. Actually, let me bring back A. Let's evaluate that. Let's go with A is equal to, and you can see that we get much different values for using log points versus log space. But let's delete these two. And again, I want to go back to this function that I made up here, and I want to graph it. So I'm going to create a couple of different variables to use, and I'll call the first one log range 1, logarithmic range underscore 1. Then I'll use the colon key for the definition operator. Let me scroll back down to the vector and matrix group, and I'm going to find that log points. Where are you? Oh, right there in front of my face. Let me double click on it. And so I need a whole bunch of different points in here. And this is one of the convenient uses of these log points and log space functions. So let's go from a minimum value of 0. And again, this is the exponent, 10 to the 0. I'm going to start out with a value of 1. And then for the number of decades, I'm going to enter in a value of 8. And let's get 100 points per decade. I'm not going to bother evaluating this because the number will end up being huge. I'm just going to have a big giant vector to evaluate over. And let's create another one. Let's call it log range 2, and then colon key for enters. Now I will scroll up to the log and exponential group. Let's double click on log space. And let's give the values here. I'm going to start out with a value of 1 for the minimum frequency. And I'm going to type in 10 to the 8, 10, and then let me use Shift 6 on my keyboard for the exponent, 10 to the 8. And let me do something different. This should give me like 800 total points. Actually, let's do something similar. Let's do 800. And if we want to, we can evaluate these. These are going to give really big vectors. Log range underscore 1 is equal to, and you can see that there are a total of 799 values in here. Let's evaluate log range 2 very quickly. Log range underscore 2, and this is going to be equal to, and here are different values, and we can see that we have a total of 799 indices in here, a total of 800 different values. But you'll notice that our numbers are different here when we're logarithmically spacing over this entire range as opposed to getting a certain number of points per decade. But anyhow, let's start doing our graphing. Let me delete this. And let me change where I want the graph to be located. Let me click over in the left-hand side. Let's go to the Plots tab and then Insert Plot. I'm going to insert a regular XY plot. And so for the y-axis placeholder, I'm going to use my f of x function, but instead of passing a value of x to it, I'm going to pass to it that first logarithmically spaced variable that I created, log underscore range underscore 1. And let me go to the other placeholder. For the x-axis, I want to have log underscore range underscore 1. And let me click outside so you can see the graph. Let's make it a little bit wider, and I don't need to see these different axis expressions. Let me turn those off so when I click outside you can see how big it is. Let me just move it over a touch and drag it out a little bit wider. All right, so here is my graph, and you can see it go around here. And let me scroll down and make this a little bit taller, see if that helps the look. And let's go to our trace color. I'm going to go to more colors and let's create a pure blue color. I like a nice blue color. And let's make the trace thickness a little bit thicker. And so there we can see how we've evaluated all the way up to a value of 10 to the 8. And so that's good for the first graph using the first range variable. Let me select this and I will right mouse click and hold in order to use the copy command. You'll notice that it is the standard keyboard shortcut of Control C. Let me scroll down, and I'm going to scroll down so I can get a second sheet on here. Let's choose Control V so we have the same exact graph. And let me change this to use the other range variable 2. And go down to this one and change this to range variable 2 as well. And click outside. And so, yeah, this one looks the same. Now, where we'll see the real advantage of doing this is by changing our XY plot to use logarithmic scaling. So right now when I click on the first graph, you can see that the x-axis scale is still selected. So if I choose logarithmic scaling, hey, now we're getting a logarithmic scale on the x-axis. You'll notice that my function looks pretty cool. You might be wondering, hey, Dave, how did you come up with that function, which is essentially a couple of sine waves every decade? Well, I had to do a little bit of math in order to come up with this. And so there we can see our first graph, and let's go down to the second one and do the same thing. Let's select this, and we can see that the x-axis is still selected. Let's go to logarithmic scaling, and hey, we end up getting our couple of sine waves over each decade here as well. And again, the reason that we were able to plot these different things is because we had our different range variables created. Let me drag this up a little bit so you can see everything together. We had our range variables created with logarithmic scales. So let me pull this up a little bit again. I want you to see the graph and the function. So we've got this function plotted using our log points function and our log space function. So again, use these tools when you need to evaluate different functions or data over logarithmic scales.